every day. I'm going to record whatever we do, if it's like content or whatnot, and post it and share that YouTube link and all of that. Um,
Are we having one every day?
well, I will be here every day. Sometimes it might be to answer questions. Some will be longer or shorter than others. So I'm gonna, let's see, share this.
It's gonna be at 2 every day.
Yeah, I scheduled one, so it should show up in your calendar. Apparently, Gauntz has scheduled
Except
physics.
for weekends.
Well, yeah, I'm not. If people really wanted to do something on the weekend, we could. Uh, that's the call. So this is my calendar if it moves over. So like it's scheduled every day. If we let's just this, I did the same thing just to keep it simple. For like pre-calc tomorrow, I said, well, I'll come on and I'll do a couple more examples because I kind of gave them some questions and an assignment, and I might do that tomorrow for this. We're going to talk about drawing Lewis structures, so tomorrow I'll come on and do a couple just with you quick and go from there. So hopefully we're all good to go. I don't know. It's like some screens I can see how many people are here. Hopefully people have connections that are stable enough that they're able to stick around, because I've seen some people come in and out, but and Ryan's not here. So on Friday, Friday, we went over quickly ionic bonds, transfers. An electron goes from one to the other. Covalent bonds or molecular bonds are all nonmetals. So these are things like sugars and big biomolecules and amino acids. Um, and they do it with sharing. So today we're going to talk about drawing some pictures of these. Somebody I think has their volume up because I'm hearing myself twice. I don't know. It could be me. I don't know. Just she's still there. The monitor isn't super bright, so it's hard to see. We talked about the one, two, three, four, five, six, seven diatomic molecules that you need to know. The Brinkelhoff ones, that we'll talk about that more when we get to equations, why that has to happen. Bigger ones, how do bonds actually form? It's the whole idea of hydrogen atoms get closer and closer and closer, and then you get this overlap where those two electrons are, well, that hydrogen counts as two. That hydrogen they count as two. So it's, we get sharing. We talked about bigger ones. So we need to know how to draw a Lewis structure. And if you take chemistry 12, you're going to do a whole bunch of these in a simple fashion for organic molecules. And it all, like, these are some long convoluted steps, and it's reads more complicated than it actually is. So it may seem to be overwhelming. Today we're going to go through and we'll do water and ammonia, carbon dioxide, hydrogen cyanide. Um, and I may say, here, try these ones, and I'll come and do some of those ones tomorrow, and we'll go from there. So a Lewis,
What's the Brinkelhoff thing again?
so those seven elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, in their elemental form, where it's just the element. They don't actually exist as a single atom because they're so concerned about pairing up or getting that octet that, like, you can get sodium as a metal and it's just all sodium atoms. And you can get different things, but those seven always, like, if you separate or whatnot, get them as elements. They don't actually exist as individual atoms. They'll pair up instantaneously because they're happier. Because like fluorine is probably a nice example. Each fluorine has seven. Well, seven is really close to eight electrons. I think that's the one I want. So if they pair up and you get this overlap, uh, well, now we have everything has eight. They're significantly happier. Hmm. Neighbors are chatting. Sorry. And it's really all about that octet. They want to have eight, and any stable molecular compound, every atom has, well, unless it's hydrogen, eight electrons around it. And there's a number of different ways that we can do that. So how we do that and how we represent it are Lewis structures, and we did dot diagrams a little bit in with ionic compounds. So the problem with chemistry is there's kind of overlap and things you do things kind of the same way. So I talked about Lewis structures in chapter 7, but I was really talking about the dot diagrams and the transfer. Now we need to do Lewis structures for larger things. So for any of these, the important thing, as with anything, calculate the total number of valence electrons. Hydrogen has one, like the groups across the periodic table, 1, 2. Other than hydrogen, we're generally going to be dealing with boron, nitrogen, like that P block, so 3, 4, 5, 6, 7. So it's we're going to have to arrange things, and like these two have CH3NCO and CNO are very different. We're going to start with small things where it's a little bit obvious. Um, Central atom is usually the most or least.
These notes will be on CM too, right?
Yeah, like they're still in here somewhere. And I changed, I cleared some stuff. Chapter 8 notes, like those are what I'm working on now, and then I'll update that completed one later.
Sounds good.
It's usually the least electronegative. It's kind of tricky. Hydrogen is never in the middle. Your central atoms are normally going to be carbon, nitrogen, oxygen. And because nature is wonderful, whoops, not symmetric, sim, nature likes to have things balanced as a mirror, as being able to rotate and get to the same idea. Like water exists as it is, and it's all about symmetry. Um, so when we arrange them, normally there's some indication that atom's in the middle, that atom's in the middle. Or in this one, we have a little bit of variance, um, but we give you some hints in terms of grade 11. Um, I will make sure that you have some idea as to what's in the middle and how to do things. If you can't do a Lewis structure how you set them originally, we have to think about bonds formed, and we'll talk about that. We're going to add electrons to make bonds, and then we have to kind of fill total things in. Add lone pairs to satisfy the octet rule, especially in period 2. These have to have 8. There's no ifs, ands, or buts. Hydrogen only has 2. Beryllium can end up with 4. Boron can end up with 6. They're kind of special cases. For this semester, we'll look at boron more. Beryllium is a little bit more rare. Boron, there are boron compounds. Uh, Total of the number of electrons counting bonds as 2. If the total exceeds the number of valence electrons, then we have to deal with double bonds and we'll talk about that as we go. If there's less, we have to add. So this is if after you have all of your bonds, if you have electrons left over. Uh, Atoms in period 1 can have only 2 electrons. Hydrogen's the only one we're talking about. Period 2 has 8, so those ones have 8. Boron has 6. After that, we get a little bit more tricky. So it's all wordy and this and that. So the first thing we need to do, we're going to start with simple old water. Most of us know what that looks like and all of that. Hydrogen. How many valence electrons does hydrogen have? Each one has 1, but there's 2 of them, so there's 2 electrons from hydrogen. Oxygen has 6. There's only 1 of them. That was supposed to be an X. So there is 6 electrons. So we have 8 electrons in total. And that's the first step, and that's straight from your periodic table. In case we forget, because it's been a few days. I think it's on this page. Oh well. 1, 2, 3, 4, 5, 6, 7, 8. We don't do a lot of. We can draw Lewis structures for xenon, but again, not something we really need to worry about. So we have 3 things. Which one of those is likely to be in the middle? This is a case where it's not the least electronegative. Oxygen goes in the middle. We want some symmetry there. So we need a bond in here. How many electrons are shared in a bond? 2. So the 2 electrons go there. 2 electrons go there. How many, electrons have we used of our 8? So we've used 4. So we have, some people like to, whoa, come on. There we go. We've used 4. So we have 4 electrons left. Can we put electrons around hydrogen? Like if we do our kind of old cover-up trick, that hydrogen has 2, it's happy, so we can't really do anything. This hydrogen over here has 2, it's happy. Now I need another box.
Do you always put the one with the most electrons in the middle between the ones with the least amount?
Uh, Not really, because when we get fluorine, fluorine's got 7. It's not. It's usually the least, but hydrogen's never in the middle. So carbon, like those ones are going to be your more common ones in the middle. So oxygen only has 4. Okay.
How do we know what one to put in the middle?
I will give you some indication at the start. Uh, um, Eventually, it kind of becomes a little bit second nature. Carbon's always going to be in the middle if it's got a bunch of other things. And we're going to do a couple of examples and talk about more as we go. So oxygen only has 4 electrons. Well, we have 4 left. So I can add 2 here and 2 there. So now we have 8 electrons in our molecule. So that's good. If I look at oxygen on its own, is oxygen have its 8 that it wants? Yeah. So I kind of drew this with different colors. These 2, because they're in between, these are bonding electrons. They're what makes the bonds. So that's in between. These 2 red ones up here, you'll hear me talk about lone pairs. Those are extra. Those aren't involved with the hydrogen. So when we draw these, what we do is we substitute, instead of those 2 dots in there, we have hydrogen, oxygen, hydrogen. Instead of that bonding pair, we draw lines. And then I keep talking about that, but I'm going to have to remember to try to turn the volume off. So there's the Lewis structure for hydrogen. In that line, every single line represents
Two.
2 electrons. So there's 2, 4, 6, 8. That's how many we want. And there is the Lewis structure or molecular structure for water. And
Wait, so I don't get it. What's the second part?
what's the second part? What do you mean second part? From this to this?
Oh, like yeah.
Well, we arrange them. We put oxygen in the middle because hydrogen's never in the middle. It's somewhat symmetric. We added lone pairs to give everything its octet. I kind of did it in 2 steps. I put the 2 in between, so the hydrogens are happy, and then we added those other ones, and everything has 8. So the electron total number of electrons exceeds the valence electrons. Well, then we have to use double bonds. This one we don't. If it's less, we have to add. We didn't have to do any of that. And wow, that's a lot of lines along there. Sorry. So it's all about adding electron.
Like, it's not making sense to me.
Well, let me do. Like, we're not going to ask you to draw anything super complicated. Some of the, even if you've looked at the assignment, this is what you have to do on the assignment. I think like, there's only so many if you kind of scan down through here. Like, we really only need to worry about a couple of shapes, and that dictates how things kind of work. So we're going to do a few more, and whoa, let's see if I undo that. So ammonia, we've got, that was a really bad N, nitrogen, and 3 hydrogens. How many electrons does nitrogen have? 5. There's only one of them, so we have 5 electrons there. Hydrogen has 1. We have 3 of them. So we have 5 valence electrons, 3 valence electrons, and so that gives us 8 valence electrons again, which is kind of a bit of a running theme because 8 is the magic number in chemistry. So which one of these, nitrogen or hydrogen, is going to be in the middle? Can hydrogen ever be in nitrogen's always going to be in the middle because hydrogen can't be. Apparently, I did drew that in 2 pieces. I don't like it. Whoops. Nitrogen goes in the middle. I'm going to put hydrogens around it. So we've got 8 electrons. Can we put electrons in between to make the nitrogen or the hydrogens happy? Sorry.
No.
Well, I've got 8 electrons. Can I put 2 electrons here? Is that hydrogen happy?
Yeah.
I've got 2 electrons in here. Is that hydrogen happy?
Yeah.
2 electrons in there. That hydrogen's happy. So I've made my bonds, but we've got 2
Wait, so
electrons. Oh,
hydrogen's happy with only 2?
yep. Do we
What
remember
is that?
why? What row is hydrogen in?
The first one, 1S.
It's in the
1S.
1s1. So hydrogen is up here, right?
Mm.
Oh. So hydrogen only has 1 valence electron. It's all about the noble gases. If we go over to here, okay, that's not letting me draw an arrow. How many valence electrons does helium have? 2. So the only orbital that's really available for hydrogen is the 1s, and we can only put 2 electrons in there. So hydrogen is that exception. Everything else wants 8 except for hydrogen and helium, and that's why we kind of at one point talked about them being some people put them up and above because
Okay.
they want 8, but really they want their outside orbital to be full, and for them the only outside orbital they have is the 1s, so they only want 2. So
Because you can only put two in the first orbital, right?
that is correct. So
Because they
2, 8, and then we get into the Ds, but we're not going to deal with d orbitals in terms of valence electrons because that's a whole other kettle of fish that is first or second year of university. So we've got two, the hydrogens all have their 2. We've got 2 electrons. Is the nitrogen happy?
No.
Nope. But we've got 2 electrons left over. So, and I can't really cover, and well, I can. It's just it takes longer. The nitrogen now has how many electrons around it?
8.
So, whoops, it's happy. Apparently, I need to remember to take the pointer away. Go away. And everything is happy. So these blue ones in between we can replace with lines. So I can do an H. I can put a line here. H, put a line there. H, put a line there. And then we have these 2 electrons that are left over. And there's the Lewis structure, or the structure, or whatever. Technically, this is a Lewis diagram because it's got dots. This is a structural diagram because it kind of has lines instead of it, but each one of these lines are a bond, and each
I don't
bond.
understand. Like, what's the second part for?
So this is just like to simplify. It's the same thing. These represent the same thing, but the first one is about counting electrons. This is about drawing a structure because we don't want to have dots everywhere.
So that's a Lewis structure, the second one.
Yeah.
So we have to do that on assignment. Do you want us to do both? Like show you do like the amount
Yeah.
of electrons?
So I will just pull that up quick because that's a wonderful question. This is like after today you can start. I thought I could just.
Start the assignment.
You can start doing part of it.
How much questions is
Come on, back. I don't want that. Oh, maybe I do want that. Huh? View student. Oh, okay. So there's 10 molecules in the assignment. Each one of them you want 4 things. And apparently at one point I simplified. Draw the Lewis structure. Um, so apparently I might have to edit that a little bit because it's out of 20. Really, there's 4 things. I'm not sure. I must have changed it. The Lewis structure is this.
Oh, you're counting that for points?
I'm counting to see if you did it. There's no points. Like if you're planning on taking chemistry 12, one of the big units is organic chemistry and you have to do this sort of stuff in here.
Word up.
So technically this with the dots is a Lewis structure. This down here is a struct structural diagram. And then we're going to talk about shape and polarity uh, later this week. We're just going to look at it quickly. Um, you like in on that assignment, even if you have the structural stuff done and have some of the shapes, we'll be all right. So are we good with that? That's ammonia, nice simple molecules. Whoops, someone's.
I have a question.
Go ahead.
Does it matter, if like the hydrogen or whatever is on top? Because I did mine on the bottom.
Like this?
Does it matter what way?
Nope. So like if you like, I did it that way just because that's how it kind of fit. You can do it like this. Some people depend, and it will depend on what you're actually using these for. Like you can, all of these are the same, and this is the crappy part of doing this here. If you build all of these, like it rotates. So it kind of, it's the same thing regardless of orientation. And that's something that I've got to figure out. I'm sure there might be
So what
a,
happens if you have more than 4?
if you have more than four, when you have more than four, that's when you're going to end up with two cent two central atoms, and we'll talk about that. Something like these three or that.
Yeah, like hydrogen 6 and stuff.
Yeah, and like this is how I would always start. Like these are the water is the first one. And then we go to ammonia. Then we're going to look at carbon dioxide and hydrogen cyanide. Carbon dioxide is the whole environmental one. We breathe out too much of it. We produce too much of it. Blah blah blah. All of that. Hydrogen cyanide (HCN) is very bad. Will kill you very quick. All right. Carbon dioxide. Nice and simple. We have one carbon, has 4 valence electrons. 2 oxygen, each one of them has 6, so we have 2 times 6 is 12 valence electrons. We have a total of 16 valence electrons in this case. Which of these two do you think is going to be in the middle? Which one has the lower electronegativity?
Carbon.
Carbon. So we put carbon in the middle, oxygen, oxygen. All right. So now if we go through kind of those rules, and this is the hard part for me. Uh-oh, what's going on? Oh, my wife has a meeting and they were out on the bicycle. Did you fall? Oh, that's good. Ben got a bicycle for Easter, so we're going through. Um, this is kind of these sorts of things is kind of the instance where teaching chemistry is tough because it's like I've done carbon dioxide so much that it's like, oh my gosh, I just draw it and I don't have to worry about it. So the first thing we need to do is put electrons in here. So we need to join them. So I'm going to do this and this. So there's 4 of them. Let's start on the outside because the things that are electronegative are the things that are going to want electrons. So if I put oxygen, well, it's got 2. I need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now this oxygen, whoops, just move that over a little. Is that oxygen happy?
Yep.
It's got 8.
Yeah.
Is that oxygen happy? Yep, it's got 8.
Yeah.
So now it's 2, 4, 6, 8, 10, 12, 14, 16. So I've got 16 electrons already on here. Is the carbon happy?
No.
Yes.
Is it? How many electrons does the carbon want?
8.
Oh.
Carbon wants, everything wants 8. So, oh, okay. Well, I'm just going to throw electrons on there. Well, that gives me 20, which makes no sense. So, this is where the fun begins.
No, it doesn't.
Oh no, this is what we're going to do is I'm going to get rid of those. Like I put those way over on that side. What if I move them, whoops, over here? Oh, I want to change the color. That's, sorry.
Can't you not do that?
Pardon?
Because then they're just. Can't you not do that because then they're like that's what's the combining thing?
No. So if I move those 2 electrons over to here and these 2 electrons over in here. Now let's go back and look. Well, does that oxygen have 8 around it? 2, 4, 6, 8.
Yeah.
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 Does that oxygen have 8 around it? 2, 4,
Mm-hmm.
6, 8.
Yeah.
And now let's see if I can do this. Okay, I guess we're going to put this over here. Does the carbon have 8?
Yeah.
So what is going on here is how many bonds are there between each carbon, the carbon and each of the oxygens?
4.
Well, there's 4 electrons. How many electrons are in every bond?
2.
So
You do two.
we need
Two
2.
lines.
So we need 2 lines. So carbon dioxide looks like that, and that's our diagram. So this is all about moving stuff around. So now everything is happy.
Question.
Yes.
How do you know that it needs 8 like around it?
Every,
Including the middle one.
everything that we're going to do besides hydrogen, like any of the things that are in that assignment, wants 8 electrons. That's kind of our goal. Sorry. Text messages and all of that. So I'm going to do like, apparently I flung that somewhere. HCN, because we went from 2 atoms types, 2 atom types. Well, is it going to make a difference if there's 3 atoms? So we've got 1 hydrogen, 1 carbon, 1 nitrogen. So we don't have to do any multiplying. 1 valence electron, 4 valence electrons, and 5 valence electrons. So that gives us a total of 10. Hydrogen's not going to be in the middle, so then we have to worry about carbon or nitrogen. Carbon is going to be the least electronegative, so carbon is going to be in the middle. We're going to put nitrogen over here, hydrogen over there. So there's our steps. Let's change color for bonds. So how many electrons do we need? We'll put 2 in between there, 2 in between there, and we get the same thing. We've got to start on the outside. Well, hydrogen, that's already happy. We're good. So now, that's not going to really work. 2 electrons, 2 electrons, 2 electrons. 2, 4, 6, 8, 10. 10 electrons. Oh, this isn't going to work because of the way this layers, so I'm going to keep drawing boxes. Is hydrogen happy?
Yes.
Yeah.
Yep. Is nitrogen happy? Yep.
Yeah.
Is carbon happy? No.
No.
So this is where we can do the adding electrons. If I went through, and I'm just going to do it here like this, if I added electrons, well, we've got too many, so that doesn't make any sense. So what we want to do is, and I did these hopefully in different colors, can I take this pair of electrons and move it over here?
Yeah.
So carbon has 2, 4, 6. I want to
Holy frick.
undo. Now, if I do stop, why does that keep? If I move those electrons over there, now is nitrogen still has 8 around it. Hydrogen still has its 2. How many are around the carbon now?
8.
So now the carbon's happy. So it's kind of like moving, accounting for different numbers of electrons. So when we have that situation where we put everything in and it's like one of them's not happy, so my structural diagram, I would put H, 1 line over here. How many lines are going to go between the carbon and the nitrogen?
3.
3. Nitrogen. Some people get lazy about putting lone pairs on atoms that aren't around the middle. Myself, those are important. If you just leave them off, well, that looks like that has 6. So some people get lazy with them. There are cases where, admittedly, especially with fluorine, chlorine, bromine, iodine, I get lazy because it's a whole bunch of dots. But that's kind of the quick and dirty. Let's draw a Lewis structure and see what these kind of look like. So we've been here for 40 minutes or so. I don't know how long I've been recording for, 35. Um, wow, I don't know why for some reason now that's doing that. These are, some of them are, which atom in OF2 would be in the middle?
Oh.
Oxygen. Well, oxygen and nitrogen these are diatomic. Those are just like the fluorine, but they're a little trickier. I'm going to just do one of those that has
Wait, so
2.
what do if they're by themselves?
Count your electrons, put your dots like that. But I want to look at, I'm going to just add a page for now. C2H6. So this is one where we've got more than 4 or 5 things. 2 carbon times 4 valence electrons is 8. 6 hydrogen. So we've got 14 valence electrons, which anything with hydrogen is usually fairly straightforward because hydrogen has 2. We're just going to put bonds in between them and go from there. So when we have 2 carbons, effectively we have 2 central atoms. So I'm going to put my carbons beside each other. Is anyone else hearing like kind of feedback, or is it just me? Actually, I think I know some of you, and I mean it's no big deal. Some of you have microphones on, and I think it's probably me hearing myself in your microphones, which isn't a big deal. Um, that's got to be what it is. So
Turn down your mic monitoring.
my what?
Your mic monitoring.
Okay,
Should probably help it.
this is where
It'll work.
I mean, it's if I'm the only, as long as I'm the only one hearing it, I don't particularly care.
Yeah, I don't know. If you turn that down, it should work.
Oh, okay.
You shouldn't hear yourself much.
Is that going to be something that's in?
Probably like your sound setting.
Uh,
Uh,
oh dear, look at this. Headphones, audio enhancements. Mm,
not there.
set it up so it's like I'm in the club. But I'll play around with it. I'll figure it out later. It's all right. So
Sorry.
we're going to have at least one bond between those 2 carbons. I've got 6 hydrogens. If we want to make it symmetric, we put 3 hydrogens around each one. So now we have those. So this is where when you have C2, or one of the ones over here is C3, um, you can have multiple central atoms. And some people will look at it when we talk about shapes, like we look at that as something and that as something. So we've got to put, those have to be bonded together. 2, 2. The hydrogens now are all happy. 2, 2, 2. The carbons are all well, all of the hydrogens are happy. Now we have to look at, and this is going to get a little bit tricky, the carbons. Well, and I know what the answer is, but Again, experience. Are both of the carbons happy?
Yes.
So there's 8 around that carbon. Oh dear. Uh, there's 8 around that carbon. Well, just because of overlap. There's 8 around that carbon. So both carbons are happy. Now I need to get rid of all of this baloney. So if I want to convert that into a structural diagram, see, there's one pair of electrons there, H, 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 and that's what the structural diagram for that would be. When we talk about shapes, we have to talk about that, but again, because of time and whatnot, this is stuff we would have
Yeah.
been.
Sorry, I was talking to my mom. Why is the the ones in between the C, the valence electrons, different colored?
Uh,
So that's important.
kind of, when you have two central atoms, they have to be bonded together. Like, we can't treat them as separate. So the first thing I would do is, if I have multiple central atoms, if I had C4H something,
Yeah,
what we would have is 4 carbons in a row. These have to be stuck together if there are 4 carbons in a row.
like
So
always.
yeah, you're always going to, and sometimes there's, when you take chemistry 12, you'll find all sorts of different things. And even one of the questions on the next page would be kind of important. But that has to be there first, because if that's not there and you fill everything else up, well, it's not one molecule. You would have 2 separate things. So
Yeah.
kind of homework or whatnot. It's not really an assignment. Well, I've done that one. Try to draw some of those. Tomorrow I'll come on, and instead of, like, well, kind of my plan is tomorrow I'll come on for a little bit if you're around, or if people missed it, and I'll go through how I would do all of those. That one is a little bit tricky. That one,
So like we're gonna go over all those tomorrow.
yeah, and that's really probably all we'll do. And then I left this in here, polyatomic ions, which we talked about in uh, a little bit in chapter 7. You can do Lewis structures for them, and then this is all different things, and then we'll talk about the next thing. That's the other thing that's important in here is shape, and I'm going to cut down. This is the table that normally you would all get that on a piece of paper, and we would go through and count. And
What is that?
this is the thing where, like, if I had been smart when I was allowed to go back into the school last week, I would have grabbed a model kit so I can build these and kind of hold them up. I might have a handful of atoms here. Shoot.
Are we gonna learn like all these shapes too?
We're going to talk about them. We're not going to be able to do, like, different. There are some basic shapes. Trigonal, water is bent and linear. We'll talk about them, um, and try to do something, and then talk about polarity. And hopefully we can kind of finish a lot of that stuff. Like, tomorrow we'll go through some of those Lewis structures together. And then if we have time, we'll talk about shapes and polarity. But my kind of goal, because this is just, so if you take chemistry 12, when your teacher, whoever it may be, says, okay, we're talking about the shapes, you've at least heard it. They're going to know that, well, you didn't have the normal spend 3 days in class on it and get to play with the model kits and build things and look at things. But if you've heard some of them, you'll be able to kind of process and all of that. So does that sound good? And you can look at that assignment. The first part is doing a Lewis structure to figure out how it's bonded, and then the structural diagram. That's kind of, if you, like, there's 10 questions. Um, well, nope. All these things that we won't get to do. Don't know what touch mode has been enabled means, but I don't know why there's 4 pages. Or was I a Dankin gonna make? Oh, I know what that is. This is being. Oh,
You're having deja vu.
no, I think it's this smart ink thing that I wanted off.
Is the assignment only 1 page or 2?
It should be 2.
Okay.
That's just
Um,
10 questions.
yeah, but like it's out of 20. One of your marks is for doing the dot diagrams and that. Oh,
What dot
oh.
diagrams? Like the ones for homework?
Well, yeah, the same idea.
Right?
Yeah, the things that we kind of did today. If half of the marks on that, if I were to give it to you, oh my gosh, would be
Things worth points right now. You're just gonna like.
this part. But if you can try it and do it, and because it's, we got an email last night about the district is still trying to clarify the credit versus enrolled bit. So what is being expected of us and you, even because we're all learning on the job. Um, so if you do that and take pictures and show me that you can do a Lewis structure, I can put a check mark and say, okay, well, and when we do naming, it'll be, can you do enough naming for me to say that you could do a credit? And it's like, I think I said at some point in one or both of the classes, it's like, I know most of you. I know if you were in the room every day, the vast majority of you, as long as you did the work, are capable of doing all of this stuff. So as long it's just a matter of showing. But if you sit here and listen to all of this stuff and don't do anything, well, you'll still be allowed to sign up for Chemistry 12. It's again, it's the more you try and practice, the easier chemistry will be down the road.
So you want us to do those questions for homework and then
Yeah.
pick them, submit to your
Oh
group?
no. Like you can just try these and we'll go over them tomorrow. I'm not going to assign them like an assignment. The assignment will be, can you do the 10 that are on that page? And if you can do the structures of those 10, well, there we go. We've got some stuff, and but we'll talk about polarity and shape a little bit when Thursday, Friday. Does that sound good to everybody?
Sounds good.
So just try some of those. We'll go over them tomorrow, and then we'll kind of kill the rest of Chapter 8 this week.
Alright.
Everybody happy? All of these
Sounds
people
good.
who are muted.
Sounds good.
Awesome.
Yep.
Thanks, everybody. Have a good afternoon.
Thank
Go out
you.
and enjoy the sun.
Thank you. Bye.
Bye.